Statistics, lecture 3. Before this, what we have already done is the mean median mode of ungrouped data, mean median mode of your group data, in which your single data and the range of data has been used. Now, in this lecture, we'll be working on range of data, but range of data will be used for histogram. Now, with respect to the histogram, it is very important for you to understand that your histogram are of two types. One is with equal class width, and the other one is with unequal class width. Now, equal class width means, for suppose if we say if x is greater than 0, less than equal to 5, x is greater than 5, less than equal to 10, x is greater than 10, less than equal to 15, x is greater than 15 and less than equal to 20. Whereas if we talk about unequal classes, if x is greater than 0, less than equal to 5, now we will have difference more than 5. That means it can be 15. So that means 5 and 15 has difference of 10. Similarly, if we say if x is greater than 15, less than equal to, let's say, 30, if x is greater than 30 and less than equal to 35. So when we work upon histogram, you will be having data, and both the data will be considered or summarized through the class width of it. If the equal class width is there, that means your range will be all equal. That means each of the class width have equal difference. This has 5 difference. Similarly, 5 to 10 has difference of 5. 10 to 15 have difference of 5. 15 to 20 have difference of 5. Similarly, when we talk about unequal class width, if you see 0 to 5 has difference of 5, but 5 to 10 have difference of 10. 15 to 30 have difference of 15. 30 to 35 have difference of what? 5. So each of the class width will be determined through its difference. Now, when we have equal class width, your histogram will be constructed through the help of frequency that will be given in the question. Your histogram will be constructed with the help of frequency that will be given on the question. Now, if the data has an unequal class width, then the histogram will be based upon frequency density. Now, frequency density is basically the ratio of frequency upon the class width of that particular class width data that is given. So that means frequency density is the ratio of frequency upon the class width. So in this case, you will be thinking of two things. Now, if the question directly hits you with draw the histogram, or any histogram is given, then you will be thinking about one thing. You'll be thinking about one thing, and that is your class width equal or unequal? So this is the first thing that you will think, that is your class width equal or unequal. If your class width is equal, checking the differences, then you will think about frequency that is given in the question. If the class width is unequal, looking at the data, then you will directly think about frequency density. Now, this frequency density has to be calculated every time. This frequency density has to be calculated every time. And the frequency density formula is frequency upon class width. Every time your frequency will be given, and the class width difference will be taken in the denominator. In some cases, in some cases, there can be reversal of frequency density. In this case, what you need to understand is that you will be given frequency density. You will be given frequency density and you will be given class width. Now, when I say it will be given, it can be given through diagram or a histogram will already be there, and the frequency density will be again through the diagram itself. So with the help of frequency density and the class width, you will be able to find the frequency itself, because your formula says frequency density is equal to frequency upon class width. Now in this, if you see, if the frequency density is given and class width is given, that means the difference of the class width, this class width will be multiplied by what? Frequency density. And then when you multiply your class width with frequency density, you will get what? Frequency in it. You will get frequency. So your data will be depending upon two things. It will be equal class width or unequal class width. If it is equal class width, it will be depending upon frequency. If it is unequal class width, it will be dependent upon frequency density. Now let's just go through the example of frequency histogram, right? So let's say we are making histogram, but your histogram is dependent upon the frequency. And how do you relate this? That how your histogram is dependent upon frequency? When you have equal class width. And if you see that 2 to 3 has difference of 1, 3 to 4 have difference of 1, 4 to 5 has difference of 1, 5 to 6 has difference of 1, 6 to 7 has difference of 1, 7 to 8 has difference of 1. That means each data that is given in the range has difference of 1. So what is this exactly saying? The time taken for each member of the group of people to run the kilometer were recorded. That means your time comes under your x-axis. Time comes under your x-axis. Your frequency is always in your y-axis. Your frequency is always dependent upon your y-axis. Now, considering this, what you need to understand is that your chart or the graph will already be given to you. Now, considering this, let's just draw up a line on this 0, because 0 is there. So we can just draw up a line. And if you just see that 1, 2, 3, 4, 5, 6, 7, 8, 9, time data is already given here. So we just need to place the frequency data. Your frequency starts from 0, it ends with 0. Your frequency starts with 0 and ends with 0. Whereas your frequency maximum value is 5. So what we can see is that this can be taken as 1, 2, 3, 4, and 5. You can go up to 6 as well, but there's no point of going till 6 because your maximum data goes for frequency is still 5. Now, if you just see and note that your 2 to 3 is 0. So obviously, if 2 to 3 is 0, we should not be drawing anything here. But your 3 to 4 frequency is still 4. So if we just draw our frequency here from 3 to 4, that goes up till what? 4. Use proper scale and pencil on this. This will be 3 to 4. The bar will be, your bar will be made. But obviously, it's a histogram. Your bars will be combined. Now, let's say 4 to 5. If it's 4 to 5, the frequency is 5 here. The frequency is 5. So we'll start from here because it's the same line that we continue. We'll go up to 5 and then we drop it down till the x-axis point that is represented for time till 5, because 4 to 5 is represented by 5 itself. Similarly, 5 to 6. Now 5 to 6 is frequency is 3. So 5 to 6, you will draw a line from here because this line is already the representation of the bar, right? So we draw up from 3 and drop down till 6. Similarly, we have 6 to 7. Now for 6 to 7, your line will be from here till 7. So this will be your representation of what? Histogram with frequency, because with frequency, you will be looking forward for what? Equal class width. You will be looking forward for what? Equal class width. Remember this, that your frequency histogram is made because of equal class width, number one. Number two, bars will be joined together. Bars will be joined together. If bars are not joined together, that is known as your bar graph. If bars are not joined together, that is known as your bar graph. But since you are doing histogram, for histogram, your bars will be joined. And remember, with equal class width, you will be looking forward for frequency. So this is about it for histogram frequency, because there's no much thing related to histogram other than just plotting of frequency. Now let's just work upon histogram unequal class width example question. Now see, if the distribution, the question says the distribution of length of time taken by the engineer to repair some washing machine is given in the table. Now you need to again look forward for the class width. Now, first thing first, since the question itself says that it is depending upon frequency density. Now, that means if the question is relating to frequency density, you should have it in your mind that the class width are unequal. That means unequal class width. So if let's see, 1 to 3, the difference is 2. 1 to 3 difference is 2, but 3 to 4 difference is 1. 4 to 5 difference is 1. 5 to 8, your difference is 3. So that means your histogram will now depend upon what? Frequency density. And already if you see in the example, such questions are there tested by the examiner that the half of the diagram will already be drawn. So just looking at the diagram, let's just fix the frequency density itself. Your frequency density question relates to what? Your question relates to the formula of frequency density itself. Now, frequency density formula is frequency upon class width. Your frequency density formula is frequency upon class width. So, if it is frequency upon class width, that means for each class width, you will be finding out the frequency density. For each class width, you will be finding out the frequency density. Now, let's say I need to find out frequency density. Now, for the first part, if you see that K is not, the frequency is not there, because already in the diagram for 1, 2, 3, the plotting of the histogram bar has already been there by the examiner. So in this case, we will be told to find out the frequency. Again, it will be through the frequency density formula. It will be through the frequency density formula. We'll do it, but let's just work upon completion of this diagram. For 3 to 4, what is the class width? The class width is 1. And the frequency is 5. The frequency is 5. So the formula says frequency density is frequency upon class width. The formula says frequency upon class width. Your frequency is 5, whereas your class width is 1. So for frequency density, we'll do 5 upon 1, and the frequency density will be what? 5. So if you see for 3 to 4, the diagram is already made with the help of what? Frequency density, and the frequency density comes under what? 5 here. The frequency density comes here as 5. So that means that this diagram was drawn already by the examiner based upon the frequency density. Let's just remove this thing down so that we can work upon the other data. Now, if I say that for next, if you see, you already know that 4 to 5. Again, your class width is 1 here. Your class width is 1, but the frequency is 4. But you need to find out frequency density, which is frequency upon class width. Frequency density is what? Frequency upon class width. So frequency density, your frequency is 4. Your class width is 1. So frequency density is going to be what? 4. Your frequency density is going to be 4. So what we are going to do is, we are going to draw from 4 to 5. Here it is for 4 to 5, but you need to understand your frequency density is 4. So we'll draw the line from here and we'll go by what? We'll go till 5. And here is the bar that is made. With respect to the quotient, 3 to 4 was already there. 4 to 5 we have drawn. Considering that frequency was 4, frequency divided by class width, 4 divided by 1, your frequency density is 4. Now, again, let's just work upon 5 and 8. Now, see, 5 and 8, your frequency here is 3. Frequency here is 3, whereas your class width is also 3. So frequency is 3, your class width is 3. So if we just do the working for the last one, your working for this will be frequency density is frequency upon class width. Frequency density is 3. Frequency density is equal to frequency is 3 and class width is 3 as well. So your frequency density will be what? 1. But this will start from 5 and this will end till what? 8. So if I just draw, your ones is here. If I just start from 5, I will have to end by 8. So if you see, the most common difference between two histograms that we just did was that in this case, your all the bars are unequal made. But when we had equal class width, we made sure that our bars were equal. So if you see here, with each of the difference, your bars are equal here. Now, this will always be related to the quotient when the equal class width and unequal class width is there. But since we were doing example for unequal class width, the examiner will always ask you to find out the value of the frequency as well, which is not there. Now, considering this, that we need to find out K. Considering this, we need to find out K. And K is your frequency. But for this frequency, to find out frequency, we will have to look forward to the frequency density data. What is the frequency density data for 1 and 3? Your frequency density data is 2. Your frequency density data here is 2. And the class width that we have is 2 as well. The difference in the class width is 2. So if we need to find out the value of K, so what are we going to do? We are going to make sure that we write down the formula, that is frequency density is equal to frequency upon class width. Your frequency density is 2. Your frequency is not known, so that is known as your K, whereas your class width from 1 to 3 will be 2. So in this case, if you understand that the value of K will be, when your denominator of 2 gets multiplied with frequency density, it should be 4. So we got to know that the value of K is 4 here. So that will be depending upon the quotient to quotient. When the quotient says that the frequency, you need to find out the frequency. You need to work through what? You need to work through the frequency density data that is there in the diagram. Now, here's another example question. If you just see, let's just go through the data. A group of 100 students, that means the total of 100 students are there, were asked how many minutes each spent talking on the mobile phone during one day. ये तो ज़ाहिर सी बात है, you must be doing more and more, ठीक है? कोई बच्चा ऐसा ना करे, ऐसा हो नहीं सकता. So histogram summarizes this information, right? So the question says, use the histogram to find the number of students. Now, number of students are basically your frequency. Number of students are basically your frequency who spent between 0 to 10. Now, the examiner is not asking you to find out frequency for the entire data. The examiner wants only to have number of students from 0 to 10. So 0 to 10 is here. Now, from the base, you can always have the class width. So 0 to 10, the difference is 10. 0 to 10, your difference is what? 10. And the frequency density goes up to 1.1, 1.2, 1.3, 1.4. Now, look at this. If we just look at the data more closely, we have 1.1, 1.2, 1.3, 1.4, 1.5. So frequency density is 1.5 here. Your frequency density is 1.5, whereas your class width is 10. Your class width from 0 to 10 is 10. So to find out the number of students who spend between 0 to 10 minutes talking on their phone, so frequency density is equal to frequency upon class width. Your frequency density is 1.5. You do not know the frequency because frequency refers to the number of students, but the class width you know is 10. So to find out frequency, this 10 is being multiplied, 10 multiplied by 1.5. So the frequency that you will get is 15. So that means 15 students were there between 0 to 10 minutes of phone being used in the entire day. Jannati bachche. Anyways, estimated the number of the students who spent between 25 to 65 minutes. Between 25 to 60 talking on their mobile phone. Now, again, you need to understand that. Now, you need to understand that your data that the examiner wants you to give the answer is in the mid somewhere here. This will be 25 and 65 is somewhere here. 65 is somewhere here. So the examiner wants you to find the frequency. Now, in this case, what you need to understand is, since the data is in the mid, now, as I said, the examiner will always test you in the reversal of the histogram as well. Your data comprise of what? Your 25 till what? 65. Now, let's see 25 to 65. If I say that 1, 2, 3, 4, 5. So that means your 25 will be somewhere here. Your 25 will be somewhere here. Let's just draw the line. Your 25 will be somewhere here. And this line goes up to this point. Right? But you don't need to mark 25 here, or just let's just mark 25. It's more easier. Now, if we just see that the number of the time taken from here till 60, the time taken from 25 to 60, you need to understand that this is your taking 5 minutes. This part will be taking 10 minutes. This is taking 10 minutes again, and this is taking 10 minutes. From 20 to 60, if you see, that is entirely 40 minutes. From 20 to 60, it will be, but from 25 to 60, there should be 35 minutes. There should be 35 minutes. So, and the frequency density for this is, if you just look at the data, since each of the box contains 0.1, 0.2, 0.3, 0.4, 0.5, you need to look very closely. Now, this actually represents 0.6. This actually represents 0.6. So, we'll mark 0.6 here. Now, to understand this, what you need to know is that to find out number of students between 25 to 60, because we need to go further than 60, but 25 to 60 has different frequency density. How many minutes do we have? We have 35 minutes altogether. This represents 35 minutes, and the frequency density is 0.6. So if you just see, your frequency density is equal to frequency upon class width. Your frequency density is equal to frequency upon class width. Your frequency density is 0.6. You do not know frequency, which is representing number of students, but you know the difference in the class width, which is 25. So if we just calculate frequency here, 25 into 0.6, 25 into 0.6. If we just multiply 25, this should be 25 into 6 upon 10. 25 into 6 upon 10. 25 is the 35 it is. I'll correct myself. It is 35. 35 is the base. So 35 into 0.6. So 35 into 0.6. So when we multiply 35 into 0.6, we will have 21 students under this particular box. So this will represent 21 students. But the data that was represented, the data said that the answer that you need to have is still 65. So this point is 65. And for this, you need to understand the frequency density as well. Your frequency density goes up to 1.2. Here's your frequency density. That is 1.2. So we mark 1.2 here. The difference in the class width is 5. Because now this is in the different grid. So to find out the data, to find out the frequency density for this, to find out the frequency for this, we will be using 1.2 is equal to frequency upon 5. So frequency will be 1.2 into 5. So 5 into 1.2 is 7. So now you need to understand that the data that you need to have, or the answer that you need to give, is from 25 to 65. And from 25 to 60, you had 21 students. And from 60 to 65, you had 7 students, 6 students. So this will be 6. So can we say the total is 27? So let's just correct this thing down as well. This will be 6. 1.2 into 5 will be 6. So the total answer will be 21 plus 6, which is equal to what? 27.